So here we've been given the graph of the differential equation. So this is a graph of the derivative. And we're being asked to find any local min-max points, some inflection points, and we're also going to sketch this potential graph. So what's really important is that we're looking at this as the f prime graph. Okay, so let's look at the f prime properties. Okay, so the f prime properties are when it's equal to 0, that's a potential min or max. So these are where I'm going to look for potential mins and maxes. Okay, so at 0, I have slope of 0. At 3, I have slope of 0. And at 5.5, okay, I'm going to have a slope of 0. Now I need to check what's going on with these slopes here, because there's nothing on the left-hand side of that 0 here. But on the right-hand side, for that whole region, okay, for this whole region here, that's going to be positive. So what does that mean? Okay, so that means that if the y-coordinate is positive, the slope is going to be positive through there. I get a 0 slope here. And then in this region between 3 and 5.5, the y-coordinates are negative. So if these y-coordinates are all negative, that means the slope value is negative for that whole region. Okay, and then I'm going to hit, looks like a minimum here. Okay, and then the y-coordinates here on the right-hand side of 5.5 are positive. So these values are positive, which means positive slope. So it looks like that. Okay, so we have a graph that kind of goes up, kind of goes down like that. And we have local max at 3 and a local min at 5.5. Okay, so it's fairly clear that that's the case. Okay, so what about the second derivative? The second derivative is the slope of the slope. So instead of looking at the y-coordinates of this f prime graph, what we're going to be looking for is slope. Okay, so we have slope is positive all the way from 0 to 1. So 1 is our kind of our boundary point. Okay, and from 0 to 1, the slope is positive. Okay, but what does that mean in terms of physical properties of the graph? Well, it means that the property is the second derivative is positive, which talks about the concavity. Okay, so again, we're talking about slope of the slope. So at that point at 1, there is no slope. Okay, so we cannot find the derivative of that point. Okay, so second derivative doesn't exist at that point. From this point here, just switch colors here. From here all the way down to here. Okay, again, remember we're looking at slope. So from 1 to 5, okay, it looks like there is a negative slope for that whole region. Okay, so that whole region, if that's negative slope, that means the second derivative is negative. That means then that we have a negative concavity. So that 1 then represents an inflection point. So again, at 5, we're talking about the slope of the slope. So the slope value of the slope graph is undetermined. So, okay, so we're going to have an empty set there. We can't find that out. And then from this point on, okay, for the rest of the graph, the slope is going to be positive. Okay, so it's going to have a positive concavity through that region. Okay, so we have an idea what this graph looks like. It's going to go up, it's going to go down, it's going to be kind of like a wave, right? Okay, so we have a graph. If we're going to graph this function, okay, so we're going to start at 0. We don't know where the y-coordinate is, but it's going to start at 0. It's going to go like this. It's going to go up, and it looks like it's sloping up, and it has a concavity change, and then a max. Okay, so it looks like it's going to have a sloping up like this, then it's going to change concavity. Okay, that change of concavity point there is going to be at 1. So that's my inflection point. I have a max point at 3. Okay, again, I'm going to come around, and all of a sudden it's going to change concavity again at 5.5, and then, at 5, and then at 5.5 it's going to hit a min, and then it's going to keep going up like that. Okay, so that's a potential graph of that. Now, exactly how high those points are, we don't really know, but the curvature is kind of relating there. Okay, so I'm just going to make this color code that. That green point represents the inflection points. Okay, and the red coordinate indicates our local min and max points here and here. Okay. So we need to have a change of concavity for inflection, but it does not mean we need 0 here, right? Okay, if we have a 0, that's a potential change of concavity or inflection point, but anytime we have a change of concavity, we're looking at an inflection point. So essentially, what we're looking at then, and this is a feature that I want to kind of highlight. If we have a max point or a min point on our slope graph, so this is on the slope graph. So if we have a max point on the slope graph, we're going like this. So we have positive concavity, it's positive, so it's going to be concave up, to negative concavity, which is concave down, okay, and that point is then, that transition point is going to be a inflection point. Okay, so this is f prime, and this is our f graph. Okay, on the reverse is also true. If you have negative concavity, it's going to go like that, and then it switches to positive concavity. Okay, at that point there, it's going to be positive concavity, and that point there again represents an inflection point. Okay, so this is my f prime graph here. Okay, this represents my f prime. If my f prime looks like this, I'm going to have inflection like that. If my f prime looks like this, I'm going to have an inflection like this. Okay, so it's good to understand that these max min points, so these max points on f prime give us inflection. Just redraw that. So max or min on f prime give us inflection. Okay, it gives us these points here. Okay, so that's a very important characteristic to recognize.